video clip will the practice how they measure the duration, which is the sensitivity of the bond price to the interest rate changes based on the weight of the time, the average. Uh, so here, why duration is important? Duration can gives the price changes expectation when we increase or decrease interest, so that the bond investors can estimate the bond price changes in the future, and then they can they can make an investment decision, right? It's kind of a beta in the stock. We have the sensitivity to the market, right? But it's not the sensitivity to the market in the bond, it's the sensitivity to the interest rate changes to get the price changes. So here, duration in the slide, please read the textbook, and here are more sense in focus on the class notes. First, step one will measure the duration, right? Duration, a measure of interest rate, the sensitivity, how to calculate, right? The time, weighted time average, right? By the present value of the cash flows in the future, right? And once we got this duration, and we can calculate this price changes based on the proportion to the duration, but we'll modify the durations with more sense, right? Duration divided by 1 plus the initial the rate is the modified duration that we are going to apply here, right? Yeah, because again, the delta of the 1 plus the yield is equal to delta, right? The interest rate changes. We can use simply this modified duration, right? Once you understand this whole process of making the duration, and we'll use the duration function in Excel so that you can get quickly. But you need to understand this whole process. So let's get started. Yeah, the exercise here. Calculating duration. The most of bond in real life, in practice, they usually issue the semi-annual bond, right? Semi-annual. So that's why we need to first measure the bond period first, because this cash flows incurs every semi-annual period, right? If the bond maturity is 2 years, we need to build 4 periods, right? So here, now how to get it? We can calculate here the time until payment. Time, because we are calculating time weighted, right? So here, divided by just 2 times, right? Time period until the payment, it shows years, also divided by 2. So you can just drag to the down, right? And then you got the time until the payment for the years. Now, next, here, the cash flows. How to get the cash flows? Right, 8% is the coupon, times, we need to divide it by 2 because it's semi-annual, times 1,000 is the par value, right? Every year, the same. But the last year, you must add 1,000, the par value. Then, what is the present value of cash flows? Yeah, this cash flows, now divided by 1 plus, what is the semi-annual YTM, right, the 5%, and to the power of, right, which one? Period or time until the payments, years, right, this period, right? Because what we are using is the semi-annual or the YTM, so we are using period. So let's just drag to the down, and we got this cash flows based on the period. And let's calculate the sum of all this. So we got this, the value, right? Present value of the bond. Now, once you got this present value of bond, we need to calculate, right, this present value of the cash flow weight, the weight, right? and fix. Let's drag down, and then you got this. Finally, weight. This present value cash flow weight. Now we need to, right, link finally this time period, not period, time. So here, this weight times the years. So duration is years, right? So here we got this all the time until the payment weighted by this present value of cash flows. Then what is the duration? Duration annual. So annual duration, you can just sum all this up, right? But here, actual duration of this bond is, right, this is semi-annual. So we need to now, right, multiply 2, right? We are not going to use this, the spreadsheet. This is spreadsheet because yeah, we can calculate by some the Excel function, but you need to understand this process, right? So finally, we got this sensitivity duration. What is the zero coupon bond semi-annual bond? Zero coupon semi-annual bond, you can just use the same process. Zero coupon bond doesn't create any coupon, but the last year only one, right? Only one cash flow, which is the par value. So I'm not sure if we can use this formula. Okay, let me just copy and paste. So take a look how it works. Now the last one now must be, now change it with this. Okay, so in this case, duration is the same as, right, maturity, right? So duration semi-annual is now definitely multiplied by 2. So we are going to use this duration to estimate or to measure the price changes, right? Okay, now suppose the bond A is initially selling 964.54 and the semi-annual interest rate of bond A increases from 5 to 5.5%, right? Then you need to first modify the duration. How to get the modified duration? Again, this D star is modified duration. If we apply this D and divided by 1 plus y, this part, right? This part is the modified duration, right? Modified duration times delta times 1 plus y, right? Again, delta times 1 plus y. Because here, the modified duration, if we assume here delta, the changes of this 1 plus y is equal to the changes of this, right? Then we can definitely simply apply this modified duration with this equation, right? So let's calculate modified duration. So here, once we got this duration, now divided by 1 plus, what is the initial interest rate, right? 5%. Then changes, the price changes, right? Price changes, percentage changes in the bond price. Now we can simply now put this, modify the duration, right? Times now how much percentage changes, right? From 5.5 from to 5.5% to 5%. Is that right? But here you always put negative. Why do you put negative? Because the relationship between the yield and the rate and the bond price is, yeah, inverse. So here we got these percentage changes of the bond prices. Now here we apply how much was the initial the bond price, 964.54, 54. Then let's apply this bond prices times 1 plus the percentage changes. So we can calculate the bond price 947. So again, once you calculate this based on the interest rate changes, the bond price changes, then you can anticipate bond prices, or if the market shows the interest rate changes from the consensus, then you can compare the current market prices with your calculation of this bond prices, bond value, so that you can get the arbitrage chance. Okay, you can also calculate duration using the Excel function. Here, you got this settlement date, any settlement date here, right? Settlement date and the coupon date, a coupon rate, and the yield to maturity and the coupons per year. So you can just simply apply duration here and just include everything. We can randomly put any settlement date and a maturity date here. In this case, we have the maturity setting here just 2 years. You can put any years there, right? And we got this annual the Macaulay maturity Macaulay duration here exactly the same, right? You can also directly calculate modified duration here, right? Modified duration, exactly same order with this input. And oops, where went wrong? Okay. Oh, yeah, that's correct. We got this. Not yet. Semi-annual cases. We need to multiply. So we got this. The same modified durations. Is that right? Yeah. For this, I want you to practice the bond annual duration metrics so that you can find the relationship here. I want you to clearly understand the duration rules, the relationship with the coupon rate and duration years to the maturity, so that you can understand this graph. Okay, see you in the next video clips with the convexity. You guys, bye-bye.